I'm going to start off with technical interview taxonomy. I'll be talking a little bit about different types of technical interviews you might encounter in the interview process. I'll be going over 4 sort of common types of technical interviews, and I'll tell you what they are and how you can prepare for them. Starting with the online assessment, this is popular because you don't actually see a human interviewer. It's really easy for the company and recruiters to interview multiple people at a time and not have to schedule anything. What happens is you'll talk to the recruiter and say, I'm interested in interviewing. They'll say, great, I'm going to send you a link and you'll have 48 hours to click the link, and then you'll have 3 hours to complete a coding challenge in that link. It will often send you to a website that's kind of like HackerRank, and you'll often have multiple questions, usually 2 coding questions or multiple choice questions. There's a mix. Each company sets their own questions. So if you get a HackerRank link with one company, it's not always going to be the same one. So if you're a Python developer doing algorithms and data structures, you're not always going to have the same test, even if you end up at the same website. When you write your solution, you'll have a similar development environment as what you'd have in LeetCode or HackerRank. You can run test cases, and then you'll hit the submit button. You won't be able to see the grading of your response. So if you've used HackerRank or LeetCode, you're able to run it and then submit it. You don't see the submission results. When you have it sent to the company, sometimes they also see additional information like how many times you compiled, whether your test passed when they compiled. And I've also seen cases where they have sort of a recording of what you're typing when you're typing it. This means that if you have text suddenly appear, that's perfect. They might get a little bit suspicious if they have that recording set up. So that gets to my last point. Often these are closed book, and closed book is try not to use external resources, but it varies. I'll show you what it looks like when you see the description in HackerRank, but some of them let you use the official documentation, so like python.org or javadoc. So I'll just move on. I have some example slides of what that looks like. How to prepare. This is going to be kind of the typical algorithm problem-solving questions, but they're not going to be the really hard ones. Since there's no human that you can interact with, they can't really give you hints. So they're going to try to do something straightforward and just assess, do you have the fundamental concepts, and do you know the programming language that you chose? So practicing coding questions, and then brushing up on the fundamentals of your language of choice. Sometimes the multiple choice questions will be things like, does this code compile? And it will show you a snippet and you have to say yes or no. Or it will say, what does this code output? And it will show you another snippet and you have to say, oh, well, it has a compile time error, or it'll output ABC. So getting a sense of, looking at code or reviewing code, I found it useful to just do like a fundamentals to review all the different concepts in the language. The other thing you can do is a lot of hiring sites have certifications these days, and these are online assessments where you answer those multiple choice questions. So that's a good way to practice that type of question, because it's not an algorithms or data structure question, and unless you are used to doing multiple choice coding questions, it's kind of awkward to do just out of the blue. One of the examples of where you can find the skills verification is on HackerRank, and they have, I think they call it certification, but the URL says skills verification. You can also go to LinkedIn. They have certifications. The HackerRank skills verification, if you actually choose to do one, it has coding and multiple choice, whereas the LinkedIn ones, from my experience, only have multiple choice. But they're pretty good examples of what an online assessment would be like. The nice thing about the online assessment is that you don't have to talk and code at the same time. But eventually some human is going to see your results, and it can be kind of hard if you don't have the opportunity to explain yourself. If you go to the HackerRank site and you go to do a certification and you click take me to the sample test, this is what you'll see. So it says you have 60 minutes and you have to solve 2 questions. And those might be 2 multiple choice, they might be 2 coding, or 1 of each. When you go to confirm, you have to enter your email address. But this here is the part about open book or closed book. And just to clarify, when I say open book means you can use any resource available to you, and closed book means you can't go anywhere but the web page you're on. HackerRank's interesting because it says, I will not consult copy code from any source, including a website, friend, to complete the tests, though I may reference language documentation or use an IDE. That's interesting because I can have the official documentation up and open, or I could actually solve the problems in my own development environment, which can be a lot simpler if you have code completion and you're able to compile and run test cases versus being stuck in the HackerRank environment. So it's worth checking. And it's worth checking for all your interviews, all your non-in-person interviews. I'll go over another one like this to make sure with the recruiter what resources you're allowed to use beforehand. It's not helpful to start the test and realize you can't use Google and then have to try to figure that out. So always ask the recruiter what resources you're allowed to use when you're given this type of test. On to take-home interviews. This is another one where you're not going to be coding with someone, you'll be coding on your own. This is another of those ask the recruiter what you're allowed to use. The way this one works is you'll be sent a project. I've been sent zip files for the most part, and it's going to be an entire application. So it might be an entire service or an app. And it's sort of fill in the blank. So I might be given a REST API where the APIs are there, but they haven't implemented anything. And I'll be told, implement 4 out of 10 of these REST APIs, or 2 out of 4 of these REST APIs. And I'll have to sort of fill in the blank for the application. And they often have unit tests that have to pass. You'll have to do a follow-up meeting. So you'll complete the code and you'll say, this is as much as I got done. And they'll say you have 48 hours or 72 hours. Usually it's between 2 to 4 days, and you pick. So the recruiter says, let me know when you're ready. I'll send you the zip file. And by the end of the 4-day period, you have to send me the zip file of your response. Then the interviewers will take that. They'll look at your code. They'll try to run it. They'll poke around and see, what you wrote. And then you'll have to meet with them for like an hour to 2-hour interview where you talk about what you wrote, why you wrote it. And then that's sort of the talking part. So you don't have no interaction. You have some coding and some interaction, but you're not coding and talking at the same time. How to prepare for these. You want to make sure you're familiar with the stack in the job description. If you say you're a Java Spring Boot developer, you need to be able to take a Java Spring Boot application and develop. And this means the computer that you're going to use has to be set up for that environment. So if you're normally on a work computer where everything's set up for you and you don't want the interview code on your work computer, then you want to make sure that your current computer is set up for it. So definitely before you start, make sure you've got that running, all the dependencies installed and everything. You'll also, again, want to check with the recruiter what resources that you're allowed to use. I've seen ones where you're allowed to use anything, like Google, Stack Overflow, whatever, copy paste code as much as you want. But when you go to talk to the interviewer, they're going to go through line by line and say, why did you choose this data structure? Why did you implement it this way? I see that you're using this library. How does that work? So you have to be very careful. And so the disadvantage of this is you've got 1 to 2 hours to talk in detail about your code versus half coding, half talking. I've actually been asked this question a couple of times for this type of interview. If a company is giving you code that's not complete and they're asking you to spend a few days to complete it, are you doing free work for that company? No, because they don't really want to give you a problem that they don't know the answer to. It's going to be really hard for them to evaluate you. So it's not very likely. But it does seem a little weird because you're being given a task and asked to code and produce something that works. It's a little bit different than the typical algorithm question. Next is the in-person or virtual technical interview that we're most familiar with. It's the traditional, implement this or solve that. Here I put your domain. So solve this problem. It could be implement this algorithm for this particular problem. Or if you're a QA engineer, it's design the test plan for this code. So given the code, write your test plan. And as you become more specific in your domain, so maybe you're security, maybe you're UX, maybe you're front end or systems design, you'll be asked to do more design-like questions, so writing less code. When you do have these interviews, a lot of people mix just a little bit of code and a little bit of design, or you'll have multiple interviews split up. So you might be asked, solve this reverse string or detect a palindrome. And then you'll be asked, design a system where, you have a protected firewall if you're maybe a security engineer, or design a DevOps pipeline if you're a DevOps engineer. So these can be a mix of coding and whatever your specialization is. So if you don't code, there are still technical interviews where they're going to try to evaluate your skill set. How to prepare for these. You want to try practice coding problems, like the same things that you do with all interview prep. So go to LeetCode, go to HackerRank, solve those, and that's really what these are all about. You also want to try a mock interview. With the previous two, online assessment and take home, you don't have to code and talk at the same time. It's really challenging if you haven't done any teaching before, or if you're not used to talking and doing something at the same time. So definitely try to practice that. You don't have to practice with a person, but just try to talk to yourself or your pets as you're writing the code, and try to take pauses so that it's a little more natural. Well, it's not ever going to be natural, but so it's a little easier when you do the actual interview. When it comes to design questions, these are hard to study for two reasons. One, it's such an open-ended thing and there's no right answer, wrong answer. I mean, there are more optimal versus less optimal solutions. There are two types of study strategies here. One is to get a handle on all the fundamental concepts. So if you're doing back-end design, you want to understand event-driven versus synchronous systems, different types of databases, microservices versus serverless. So all these different fundamental concepts. And then you also want to get a sense of examples. So basically read blogs, read books, watch videos on these topics. So for example, Netflix has a technical blog where they go over their architecture. And that's a great way to learn about these different concepts without having to read a textbook. So unfortunately, there's no, go to LeetCode and do 100 problems for this, but there are still definitely resources, and it really depends on what your domain is, which resources to look into. Last type of interview is the behavioral or soft skills interview. These interviews are so the company can understand if you're going to be a good fit for them. And sometimes it's also a way for them to understand, how long you're going to be at the company. These become more of a component when you're senior or in a leadership position, a manager or a project manager. But as you become more senior, regardless of your role, you're going to get more of these questions. They often start off with, tell me about a time when, or how do you handle a situation where, when you're in leadership or senior roles, it's how do you mentor? What do you see your leadership position being? For the first two, tell me about a time and how do you handle a situation, it'll be things like, tell me about a time when you had to meet a deadline, but you couldn't deliver all the features. How did you decide which features to deliver and which ones to cut? How do you handle a situation where you presented an idea to your coworkers, but they were not on board with it? How did you convince them, or what discussion did you facilitate after that conversation? So these are things like, how do you behave in usual day-to-day scenarios? Will you be able to resolve any blockers that you might encounter? How can you be productive as an employee on this team? Preparing for these, a few people say, oh, you don't prepare, you just have to wing it, which is a strategy. Depends on, some people are great at that, but some people aren't. So you can look at the company values. A lot of the times the recruiters will send you to their career page, and their career page will be like, we are Amazon and we have our 9 leadership principles, and it'll list off their leadership principles and a little blurb about them. And you're like, okay, corporate Kool-Aid, I'm not really going to pay attention. But those are the questions they're going to ask you in this interview. So picking on Amazon a little bit, they have a leadership principle called bias for action. And that one says you take action right away rather than waiting for all information. And so they really want people to move fast. So they might ask you, you know, when's the time where you didn't have enough information to make a decision, but you had to make a decision anyway? So you can look through those leadership principles and say, I'm going to come up with an example of how I displayed each of them. So you can do that ahead of time. The other one is the same thing with the job description. For any non-technical bullet point, do the same thing. So if there's a bullet point that says mentorship, you want to say, okay, I have to get an example of mentorship. So that's how you can prepare for these. And I've never been in an interview where they just randomly have this question that's not related to either the company values or what's in the non-technical side of the job description. So even though this one is kind of non-specific, it's definitely something you can prepare for. The final thing about this is they always want you to respond with the STAR method. So you want to take a look at there's this, if you Google STAR method, it's just been around for so long and there's so many different examples. It stands for situation, task, action, result. And it's a way about it's a way to talk about your accomplishments. And it's really what they look for in interview questions like this. So definitely take a look at that, and you can write out your answers in the STAR technique. That is it for technical interview taxonomy. Are there any burning questions right now before I move on into stacks and queues?
I have a quick one, Alicia.
Mm-hmm.
For the first round of technical interviews with the HackerRank, you mentioned sometimes that they can record you, and if they just see code pop up on the screen, that's kind of a red flag.
Mm-hmm.
In some of these interviews, I've used like a replit to code it out first, just because I like to see the console logs. So I've copied and pasted that code that I wrote from the REPL into the HackerRank. Is that maybe not ideal that I should be doing?
It depends on the interview sort of agreement. So HackerRank in the example I showed said it's fine to do that. So in that case, if they see something pop up, they're like, we told you could use an IDE, it's fine.
Yeah.
But for the ones that, so I was the interviewer, and so they would send me this giant file that would show me what the person was coding. And they would tell me that that person was not allowed to use any external. So in that case, if we saw code pop up, it was flagged for cheating, but that's because it was a very specific set of requirements on that one. So you just want to make sure if it's open or closed book, because they do screen for cheating. But what you described, it's fine, because HackerRank says use your own IDE. So that's not a problem.
Okay, got it. Thank you.
Okay, I will move on to stacks and queues. And I will be talking a little bit about my emails here, just in reference to the event title. I will start off talking a little bit about lists. Stacks and queues are closely related to lists, so that's why I'm going to do that segment. I'm going to go through stacks, queues, a small bit about priority queues, because they're also called queues. They're slightly different than the queues I'm going to talk about here. And then I'll move into some practice problems. Remembering lists, we have a linear structure that's ordered. And at the bottom here, I've got my 1, 4, 5, 7, my list of integers. And usually when we say lists, we mean linked lists, which means that this element here has a link or a pointer to the next element, and so on and so forth. The implementation of lists isn't really important for stacks and queues. It's just a recap. The operations that we're interested in for stacks and queues are the usual list operations, so insert, get, delete. I'm mentioning search here just as a completeness kind of thing, but we only care about insertion or deletion or get at the beginning and end. So that's why all of these are O of 1. If we have to do search or insert at or delete at, that would be a little bit different. But these are the only operations we care about when it comes to stacks and queues and how they relate to lists. Stacks and queues are often built with lists. So if you go to your language of choice and you look at stacks and queues, sometimes they don't have separate stacks and queue structures. They say use a list. And sometimes they'll put a different API on top of a list so that you can use the vocabulary that I'll bring up in the next slide. You can also implement them as arrays or any other linear structure. There are a few terms that are common between stacks and queues, which is why they're grouped together a lot. We have common operations, push, pop, peek. I've got is empty for completeness. I'll review these in a sec. So they have more restricted operations. You could, if you have a list and you're using that to implement your stack or queue, you can't do a get at index or a delete at index. You can only do a push, pop, or peek, and those are restricted to only the beginning and end of the list. So going to those operations, a push is adding a new item, pop is removing an item from the top or front, and I'll talk about what ends of the queues and stacks are. So this is just the front side, so you can only do a pop from the front, no matter whether it's a queue or a stack. Peek is return an item without removing it. So a pop is a delete and return, and then a peek is return but don't delete. And again, both of those are only from the top or the front. And then is empty is the same. So you'll notice that this push, add a new item, doesn't specify which end it's adding an item to, and that's the difference between stacks and queues. So both stacks and queues, when you pop or peek, it's from the top or front. So top and front are two words for the same end. But push, depending on whether it's a stack or queue, go to either the front or the back. I have an asterisk here because if you're interested, you can try implementing a stack in a queue where pop is different rather than push. So that's possible, but most of the time we say push is different. Here is a stack, and I'm gonna go over the vocabulary and talk about how the operations work. So here we have this stack of colors, and so this is the bottom and this is the top. So that's where bottom, top are used for stack, and front, back is used for queue. But it's kind of, you just have to bounce between them a little bit. When we talk about stacks, it is a linear data structure where everything stays ordered. The way we operate on the stack is called last in, first out. So when you push when you do a push, it goes to the top. When you do a pop, it removes from the top. And when you do a peek, it returns the top without removing it. So all the stack operations are focused on the top. And this means that when you push an item, like red, it was the last that went in. And when you pop it or go to look at it, it'll be the first that comes out, which is why we say LIFO, or last in, first out. So I'm going to walk through some of those operations, and Becca is going to keep an eye on chat. So I'm going to give you a chance to send some responses into chat if you are interested. So the first thing here is if I call peek on this stack here, what am I going to get?
The consensus so far is red.
Okay. We get red, that is right.
Yeah.
And when I do a pop, what will happen? So first, what am I going to get back from the pop?
Red.
Yeah. Red or purple.
Yeah, we've got red. And the reason why we got red is because peek doesn't do a remove. So this did change our list. Yeah, so it was red and it was removed from our stack. So after the peek operation, the stack doesn't change. After the pop operation, it does. We're going to do a push of blue. So where in the stack is blue going to end up? The top or the bottom?
Consensus is top.
All right, yeah, we have it on the top there. So we have a peak returns the top of the queue but doesn't remove it. A pop, sorry, the stack. I'm gonna make that mistake. Pop returns it and also deletes it. And push will put it back at the top of the queue. Sorry, stack. Apologies. The nice thing about a stack is because we're only operating on the top, I can put this nice little black border at the bottom. So emails, I'll get into queues. If you have your email client and you sort by date, you can change whether your email works as a stack or a queue. So you can sort of use this as a way to understand, okay, what's going to be at the top or bottom. So if I'm in my email, and I actually made sure to pile up some junk mail just for this presentation. So if I try to sort by newest on top, I'm going to be using my email list as a stack. So you can see that the newest times or the latest times are at the top, and it gets older as I go down to the bottom. If a new email comes in, it's going to go above this one here, maintaining that the top of my email inbox is going to be the most recent. And if I read from the top to the bottom, I'm reading it LIFO, last in, first out. So that's a way you can read through. Now with emails, you can read whichever one you want. But if you do go from the top to bottom, that's sort of a stack style, reading your inbox. So now I'm with queues, and I don't have this black border here anymore, which makes it a little harder to talk about operations, but we'll get to the demo. Queues are FIFO. So we previously had LIFO, now we have FIFO. And people do say LIFO and FIFO. Like sometimes you have acronyms and some people pronounce them and some people don't, but most people say LIFO or FIFO. So if you think it sounds silly, we're all saying it together. FIFO is first in, first out. Push operations are adding it to the back this time. So we have two ends where we're running operations. So push adds to the back. When we had a stack, we called this the bottom and this the top. Just to be clear that front and top are kind of the same and back and bottom are the same. Pop removes from the front and peak returns from the front. So with both stacks and queues, we take items from the top or the front, but the difference here is that push. With the stack, we push to the top, and with the queue, we push to the back or bottom. A little vocabulary note here. Even though you can use push, pop, and peek for both queues and stacks, some APIs will use enqueue and dequeue. Enqueue means push and dequeue means pop. And of course, it's kind of easy to remember that because they both have queue in the name, so you wouldn't necessarily use them as a stack for stack operations. All right, we're gonna run through this color queue again. If I do a peek, what am I going to get?
Yellow.
I see lots of yellow as the
All
answer.
right. We do get yellow. And what about a pop?
You'll get yellow again.
More yellow, but this time the queue shortens. So yellow's gone. Now we do a push of blue. Where is blue going to end up? Okay, after red, I'm seeing that. So yes, we do have it at the bottom. So we never end up getting a new item never gets pushed on the front. So the oldest item stays on the top. So going back to emails. So if you sort your emails by oldest on top, you now have a queue. So even if you get a bunch of new emails, your view of your email is not going to change because you can't add to the front of a queue. You can only add to the back. So if you can only see, your Azure free ebook newsletters, then you're not going to get any new coffee e-newsletters if they come in. So that's sort of a way you can play with your email and say, is it stack or a queue today? Going into,
could you go back to the stack, the pop on the stack?
Oh, stack, sorry.
So,
Here.
yeah, because, and I don't know if it's just like, so it looks, I don't know if it's just the way you made the presentation, but I noticed like this one, the stack remains like the same size, the stack as a whole, whereas when you popped off yellow from the queue itself actually shrank.
It can vary. So it's just the way I made the slides, because I sort of see stacks as like, you know, like if you watch older movies or movies set in older time, they have like inboxes on their desk and it's a stack. So I always view stacks as like little boxes. So that's definitely me putting that there. But if you think about the lower level side of it, you can look into the implementation. Of course, if it's an array, I think you pointed this out in one of our previous events, arrays aren't necessarily going to dynamically change size unless you're using a structure that has dynamic resizing. So if this were an array, you could potentially have it the same size and use the index tracking for it, or you could have it dynamically sized like my queue example. But it's definitely just how I drew the slides. There's no concrete restriction or requirement that they change size with the operations. It's definitely up to your implementation.
Okay, thanks.
No problem. Okay, so those are stacks and queues, and that's what we're going to try to focus on. But when you talk about queues, people bring up priority queues, and you're like, okay, new type of queue. Yes and no. Priority queues kind of only have queue API and queue as a name in common. So you can still have the push and pop operations, but it's kind of different than a regular queue. Priority means that you're not getting items in FIFO, first in, first out order anymore. You're getting it according to some priority. So I was previously using Outlook as my email example, but switching to Google because I don't like the Outlook priority queue feature. You can set it up so it ignores dates and instead applies a different priority. So you're going to see, you know, starred emails or unread emails or filter emails first instead of everything else. So whenever you look at the top of your inbox, you can't say that it's the newest or the oldest. It's whatever your priority is. For a priority queue, you can specify the priority usually in some way. Often priority queues are implemented with heaps. So heap is another data structure, which is why I say you can have a priority queue, but it doesn't necessarily have to be implemented the same way a queue is. But you do have push and pop and then queue, dequeue. So if we have this alphabetized list of fruit, we have the queue front and the queue back. It's a little misleading to have it as a list. I'm just using a list as an example if you wanted to use a linear queue. But like I said, it could be a heap. It could be something completely different. So when we do a push here of orange, so we have this O here, and so we're going to want to alphabetize it in. So I'm not necessarily going to go through audience examples because it's a little bit hard to do this. I probably should have indexed them, something for next time. But it gets inserted in the middle. So we don't have insert at the back. We don't have insert at the front. It's insert wherever it is in priority. Oh, sorry, too quick. And the interesting thing about this is if you do end up in an interview where they say implement a priority queue and you're like, okay, sort when I push, got it. But it's interesting because you can choose to sort on push or you can do a search on pop. And that's where I get into the complexity. So if you do a, so this priority queue, I'll get back to priority queue in a sec. So for our push, pop, and peek on the regular stacking queue, it's just like the list operations that I talked about at the beginning. So those are all constant time. So you mean like, great, I love this data structure. All the operations are constant time. Search being O of n, and that's going to come up in one of the interview questions that I present. For priority queue, that push, you're trying to insert, you're searching and then inserting. So that's why it's O of n. And I put a star there because you can choose to do the prioritization on push or on pop. And that's like a whole other conversation there. But for our purposes, constant time, unless you're searching, and you shouldn't really be searching because that's not how stacks and queues are meant to work. And when it comes to space complexity, if you have n elements, the stack or queue is O of n in terms of size. So we're not adding edges or pointers or anything. It's all proportional to n. Meg shared this a while ago, this big O cheat sheet, which is very nice that you can take a look at. And there's also a presentation that Women Who Code did on big O notation. I am currently talking to a potential speaker for a big O talk. So hopefully we get that going in the next month or so. When to use stacks and queues. If you go to the interview prep sites, there's just not a lot of stack and queue questions. And you're like, well, do they just never ask them? They tend to be part of other algorithm questions. So for example, if you do graph search or tree traversal, if you are familiar with breadth first search or depth first search, you can write them with the exact same code, but just use a queue in one and a stack in the other, and they're otherwise the same algorithm. And so stacks and queues come up in other algorithms like graph search and tree traversal. For other uses, there's a couple of problems I will reference. I think I put them in the meetup, but if I haven't, I'll share them. There's traversing lists back and forth. So you will be going through a list and sort of picking certain items to go on a stack or a queue and then going back and forth. And that's sort of an alternative to lists, searching. So it's kind of like you filter stuff out and send them to stacks or queues. Tracking state at each iteration. If you are familiar with how the runtime stack works in software architecture, sort of computer architecture, it tracks state every time you call a method. So this will be something like every time you take a step, you add some additional state. So maybe I have my colors stack, and every time I push a color, I'm adding the hex value, or maybe I'm adding the previous color. So I'm tracking state along with my push. And that's part of the min or max value stack problem that I'll talk about. And then symmetry or matching. There's the bracket matching problem I'll talk about. There's also, you can use a stack to determine if a palindrome is, a string is a palindrome or not, so that's kind of nice. But it's sort of like looking for pairs. And that's kind of one other example of how, when you would use it. So I'm going to stop there. If anyone has any questions about stacks and queues before I go into the practice problems. Okay. What I'm going to do is I'm going to present two problems, and I'll let you pick or vote in the chat on which one I should do first. If we have time, I'll do both, but I want to make sure that we get to the one that people find most interesting. So the first one is valid parentheses, also bracket matching. I've copied the description from the LeetCode problem. So LeetCode problem is here. I'll point out a couple of gripes I have with the way the LeetCode problem is phrased, but that's all part of, interview prep, questioning the problem. Given a string containing just the characters open and close brackets of parentheses, curly bracket, and square, determine if input string is valid. It's valid if open brackets, and again, the phrasing of it, open brackets must be closed by the bracket of the same type. Open brackets must be closed in the correct order. And then one thing they didn't mention, all open brackets must be closed. And all closed brackets must have been opened. So that's sort of an implied thing there. So the way this works is if you've worked in a language that has parentheses and curly brackets and stuff, you'll be in your IDE and it'll do like this nice highlighting or tell you a squiggle when your brackets aren't matched. So that's kind of how you can think of this problem, is that it's trying to make sure everything's been matched. So for this first example here, and these are the examples taken from the LeetCode problem. So if you're looking at it and you want to code it, right now. Instead of watching me talk about it, you can go straight into that. So for this first example where it's just one open, one closed, is this valid? We have,
Yes.
okay. I feel like I'm getting better at PowerPoint every time I do one of these presentations, but it doesn't have a check mark, it just has a happy face. So we have a happy face for that one, that is correct. What about this second one where we've got 3 different open and closes? Is that one valid?
We're also seeing yes for that one.
All right, all good there. For the third one, where we do have an open and close, so that's there, is this one valid?
No.
That is correct. They are an open and they are closed, but they are not of the right type. How about this one? We've got 2 opens, 2 closes, and types match.
A little bit of a mix there.
Yes.
Okay. So this is not correct. And this is where I find that the problem is a little low on details. You have to close in the order that you opened. So if the last one you opened is a square, you have to close, the next close one you see it has to be a square. So because we tried to close the square with a regular parentheses, it wasn't a valid match. So here, when you do like an open, close, open, close, open, close, the next close you see is the last one you opened. So that's sort of another piece that's missing here. So now we have sort of a similar one where we do have 2 opens and 2 closes of different types, but they're ordered a little bit differently. Is this one valid?
Yeah. Because it's nested.
Yeah. So this one is the kind of interesting one where I don't really feel like the question described it properly. But this is why going through the example cases and making sure you have examples is very helpful. So every question you get, try to have some clarifying questions. You don't have to, like your interviewer says, match these brackets. You don't have to like come up with the questions right away. You can say, give me a second to read the question and try to think through a couple of things to ask. So one example is, what do you do in the case of an empty string? Another one will be, how long will the string be? This isn't necessarily useful. Whenever I get an interview question, I'm like, how big is the input going to be and does it matter? So for this particular problem, it doesn't really matter unless you're getting like such a big string or maybe a giant file. Maybe you're doing a JSON parser and your JSON is too big to fit in memory. But that's not the question we've been asked. So you probably don't have to worry about that. It's always worth thinking of size of your input though. White space ignored. And these are questions that are in the LeetCode question, but I'm going to kind of ignore it because you're not going to be given the LeetCode question. And then what to do with non-bracket characters. So these are some of the clarifying questions you can ask. And again, the LeetCode problem says you're not going to get any bad characters. And I feel that that's not really representative software development. I can't just write a service or a web app and be like, people aren't going to send bad data. So I do like, implementing these checks, even if the LeetCode problem doesn't require me to. So that is problem number 1, or brackets. So I'm going to call that 1 or brackets. So keep in mind for voting. The second problem is called min stack, and that's also in LeetCode. Design a stack that supports push, pop, and peek, just like a regular stack, and retrieving the minimum element in constant time. So we have push, pop, and top. The LeetCode question says top, but I would say peek. It's a little bit odd that they, again, me and my critiques of the coding problems. Try not to do that in an interview. If your interviewer says use top and you're like, well, actually, maybe not the right time. And then finally we have our extra method, which is getMin. So the interesting thing about getMin here is that it has to be constant time. So when you, and I'll show an example of how this works through.
We get a question of whether getMin would be the same as peak here.
Yeah, so I will show that. Meg mentioned, try not to mansplain or womansplain the interviewer. So we're going to walk through building up a stack and running these operations. The example I'm going to show you is the example in the LeetCode question. So you can look at that if you want spoilers. So here we have an empty stack, and as Meg mentioned, it seems to have a size, but don't worry too much about that. We are going to push -2, and that's pretty uninteresting because it's empty, and you're going to end up with a 2. Oh, next we're going to push 0. Now, is that going to be lower than the 2 or higher than the 2 visually? All right, I'll go ahead with this. It's going to be above. So top of the stack. So this is the nice thing about drawing stacks, is that I can just put a bottom on it. So that goes on top. We're going to push -3, which is also going to go on the top. So now we have 3 numbers in our stack, and we're going to try to run these operations. So what is the smallest number in that stack right now? And that's what we're supposed to get for getMin. So what would we get when we run getMin? Seeing -3s. Yes, we get a -3. And what happens when we pop? What value are we going to see?
-3 again.
Yeah. But now our stack is different. So now I have 0 and -2. When we peak, what are we going to get? 0. Okay. Sorry, I'm just taking the first answer there. And when we run getMin, what are we going to get when we run getMin? Or what answer should we get there?
-2.
Right. So what you want to note here is that 0 is at the top. So that's what we got with peak. But -2 is actually the minimum. So -3 happened to be the minimum and the top. So if you have 100 different numbers here, when you're going through to find the minimum, to actually do a search, so remember the search complexity is n, that's linear time. And for the problem, we're supposed to do constant time, not linear time. So that's the challenge of this particular problem. More clarifying questions here. What do you do if you're trying to get the minimum and the stack is empty? This is interesting because a lot of programming languages will just return empty stack exception, which is kind of annoying. If you go to LeetCode problem, they're like, this will never happen, don't worry about it. I'm like, but I need to. So there's that one. Size of the input, again, I always bring this up, and you have to ask yourself, does the size of the input matter? It does if you're getting so many numbers on your stack that it exceeds the size of memory and you have to start writing it to file. But unless that's what your interviewer is asking you to do, which is possible, I've had interviewers say, it's going to be so big, you have to write the file. And I'm like, please don't. I'm just going to abstract that away because I don't remember how to open files in an interview. So it's worth thinking about, but you have to ask yourself if it matters. Positive and negative values. Obviously, in the example, there were negative values. One of the things is if you know there's only going to be positive numbers, then you can use negative numbers as sort of placeholders. So like getMin returns -1 if you can only have positive numbers. Oh, I clicked too far. So that is the second problem, problem 2, or min stack. For the problem I start with, let me know in the chat, and Becca will help me out with this, which one you would prefer that I go first. I walk through first. Becca, what are we looking at?
So it looks like majority are voting for the valid parentheses.
All right, brackets. I've heard this problem called a lot of different names. I'm going to stop sharing briefly, and I'm going to do something different today as I experiment with different ways of presenting interview problems. So today, if you recall from the first half of this event, it was very long ago, you were allowed to use your own development environment to solve your coding problems. So today, I'm going to be using my own development environment to solve the coding problems, which is different than going to LeetCode. One of the things that's different is I get to use, again, the autocomplete, but I'm also going to highlight another way of doing practice problems. So I have my function here. I'm using Kotlin. I hope it's readable. If there are any concerns over what does that do, let me know. I'm going to try to keep it sort of like, I don't want to say normal code, but Kotlin does have some interesting features that I'm going to stay away from, just so it doesn't confuse people. And this is just always fun. There's something called an Elvis operator. So it's a question mark and little eyeballs because it looks like Elvis because of his hair. Anyway, so I like that one. I use it a lot, but I won't use it here. Okay. So we have our match brackets. And so we're starting off. And if you are writing a coding problem in your IDE, you're like, well, now I have to, like, what am I supposed to do to test it? But that is the nice thing about having your own development environment is that you can set up your own unit tests and do test-driven development. So I'm going to go into that just a little bit. So what I've done is I've written a test suite here, and I've come up with a bunch of test cases. So I've got my LeetCode test 1, 2, 3, 4, and 5. So I've coded those up. But I've also written my own test cases. And this is something that's really worth practicing. So if you take your LeetCode problem, then you go to your development environment, and you say, I'm going to think of all the test cases that I want to test. That's going to be super useful for when you practice interviews. So I thought of my own test cases. So I have, when there's only closed brackets, what happens? Only open brackets, empty string. I'm going to choose to tolerate, like I'm going to write code for empty strings and invalid characters and extra white space and stuff like that. And so I get to decide how I want that to behave. Now, this may make it a little harder for you to paste it into LeetCode and make it work. But for the LeetCode problem, they're like, you're never going to have this happen. So it'll be fine. But I have made the decision that when I get an empty string, it's going to be valid. And it's important because, like, this particular thing is important because when you're in an interview, I've had interviews where I say, well, what about empty strings? And they're like, what do you want to do about that? And I'm like, I don't know. You're the one asking me questions here. So you kind of have to be ready to say, I think that empty strings should be valid because no brackets is matched brackets, right? So you want to have sort of an opinion there. Sometimes they want you to make decisions like that. So I made a couple of decisions where I'm going to accept white space, but I'm not going to accept anything else. So we're gonna take a look at that. So I'm going to expand these. I didn't want to have them all expanded right away, just so that you could see them all at once. But I've got all these test cases, and I've directly put in whatever was in LeetCode. And I have these assert statements. That's common in a lot of languages. So I'm going to run my method. And if I have this input, I want it to return true. So we're back at this matched brackets function, and it returns a Boolean. So I'm going to try running this test. Now, my function is not implemented. So when I run my tests, I'm probably going to get some failing. I haven't figured out how to zoom in on this part of IntelliJ, and I forgot to mention I'm using Kotlin and IntelliJ. I think I mentioned Kotlin, but not that I was using IntelliJ. So the other thing that's kind of interesting here, if you are preparing for a take-home interview prep, this is also a great way to be like, I'm going to set up my Kotlin IntelliJ environment so that when they send me the Kotlin project, I'll be ready. So this particular method can be really great for preparing for different types of interviews. So I've got 5 tests failing and 5 tests passing. It just so happens that I return true. But a few of them are like, when there's only open brackets, return false. So that's obviously failing because I don't have, it's always going to return true. So the tests are there. It's how I determine when my code is right enough. So we don't have to worry about that until we start implementing. So now let's talk about these matched brackets. One of the first things that we sort of think of is what are matched brackets? So like I have to keep track of what are opens and what are closes. So one way you could do that, you could say opens is a list of open, oh man, I don't use this keyboard too often, which is why I'm going to be looking at it a lot. So you can see these are my opens. One day I'll get it, I swear. These are my opens, and then I'm going to have a list of closes. So I'm just like, okay, now I have what my opens are and what my closes are. So this is where I start. I haven't actually thought about what I'm going to do right now, but I know that I need to know these for some reason. But we are in a stacks and queues talk, so we're going to use one of those 2 things. And I mentioned before that you can use stacks and queues for matching problems, so trying to match things together. When we talked about the examples, I mentioned the next close bracket has to match the last open. So the last open was maybe the last in on the stack, and it has to be the first match. So we're going to say last open, first match. And does anyone know which data structure, stack or a queue, we're going to use for this? Does anyone hazard a guess?
I see stack.
Yes. So last open, first match, we can think of that as last in, first out. Okay. So now we kind of know that we want to keep track of the opens and we want to match the last open. So we're going to get a stack going. And Kotlin gives me stack. So here's, again, the nice thing about these IDEs is I can hover over this in IntelliJ, and it says, did you want to import that data structure? And I'm like, yeah, I'd love to import this data structure. And it's like, by the way, you didn't use this right. I'm like, oh, okay, let me just fix that. But in LeetCode or HackerRank, I don't know if you've done the whole like compile 6 times and be like, why can't I just remember that one bracket that I needed? Or you have this really silly typo and you're like, now I have to wait 5 minutes to compile again. That's another nice thing about this. So we want to put the open brackets on the stack. And every time we see a closed bracket, we want to do something. So I'm going to start by for character.
I'm coding along in JavaScript. So would I use like an array as a stack?
You could use an array or a list. Yeah. So you could do, now this is probably going to show how rusty I am at JavaScript. So you could do val stack equals this, and then you would do, I think you can do push or append. But you'd want to make sure to take from the right side. So if you're doing an append, and I apologize if that's not the right one, but if you're adding to the end, just take from the end. So you'd be Now this is where I end up in Python, but you would do something like that in Python. Or you could do append 0. Again, I do apologize. I'm not the strongest JavaScript developer, and you could do stack 0 like that. But there's definitely going to be some API for you there. But sorry, have not done stacks in JavaScript for a long time.
Okay.
As long as you are adding and removing to the same end, it'll be fine.
Oh, Shilpa wrote in chat about your closes list.
I think, yeah, you'd think I'd notice that, but that's the that's the part about test-driven development where that's the nice thing about when you're at work and you have your tests written and you know that your code works before you show it to your coworkers, and your coworkers are like, you completely didn't implement the problem right. I'm like, oh, no. Thank you for pointing that out. But this is going to change a bit. So feel free to point out errors. Things are going to change around a little bit here. So every time I look at one of the characters in my input string, I want to see if it's an open or a close. So if character in open, I'm going to do something. Otherwise, do something else. Now I'm intentionally kind of putting bugs in places. So if you find one, it might be by design, it might not. It'll be exciting. So I've got this squiggly line, and Kotlin's going to tell me that you can't just compare strings and characters. Slight detour into Kotlin and Java. There's a difference between single quotes and double quotes, which is not true of other languages. And then we get into why I hate using IDEs, because they're like, we want to complete all of your quotation marks for you. It'll be great. Let me try to get this correct. Now, again, the LeetCode development environment would not tell you this. So you would just, I've actually looked into how to turn this off if anyone's wondering, and I haven't found a way yet. Okay, so now this typing is correct. If it's an open, I do one thing. If it's not an open, I do another thing. So if it's open, I'm going to push it to my stack because I want to say, well, there's an open, whatever the latest open is, that's the one I have to worry about. But I don't need to worry about the ones before it until that open's been closed. So I'm just going to push character. And this isn't an int character. Okay. You found box and unbox types. It's a whole other conversation. So now I push. Otherwise, I need to know, can I pop? So if I get an open character, now I've got like this string. So if I have a string that looks like this, so let's see. I'll put a square bracket here so it's a little clearer. So a string like this, I'm going to end up with a stack that first has, so here's the bottom. So we're going to get this curly bracket opening. We're going to square bracket open, get a regular parentheses, and now we're going to say, okay, well, we're not an open character anymore. What am I'm looking for something to match with this. So what am I looking for when I see this open, rounded open?
You're looking for the closing parentheses.
Yeah, so I'm looking for this one. So if my character isn't an open, I can go to the top of my stack. And this is where I can do a peek operation. So I say, I don't want to remove it. I still have to keep track of it. But I can look at it and say, is character the closing of top? And now I'm like, well, I have a list of opens, I have a list of closes, but I actually need to know what their pairs are. So what I'm going to do is I'm going to change this a little bit. So what I'm going to do is I'm going to change this to a map. I'm going to say I now have a map of opens, closes, and closes to opens. I don't actually think I need the closes to opens, but yeah, I'm actually going to leave that one alone. I don't think I need that. But I need to be able to look up for a given open, what is its close? I'm going to say this one, and this is
So maybe you should make like a, oh, okay, yeah. I was gonna say like a hash or
yes.
something,
So
but
what I'm
whatever it's
doing
called in
here,
Kotlin.
yeah. So Kotlin does this funny thing. So it's called a map. It's a map, but what it's creating is this dictionary or hash map where the key is the open. So it's like open. Oh. And then it tells you what the close is. So here, the key is curly open and the value is going to be curly close. So I have this map. So it tells me if I know what my open is, it's going to tell me which close I'm supposed to have. I'm going to change this up. Let's change it to, so now I'm not looking at a list of opens. I'm just going to look at all the keys in my open map. And then I have my top stack.peak, and this is the bracket I want, equals, so I'm going to try open to closes to give me the close. So I use my hash map where I pass in the key as the open I have, and it's going to give me the bracket I want. Okay, so I'm at a non-open character. I want to see if the right one is at the top. If current character is the bracket I want, look at the auto completion. Then now what? So I found a pair that matches. So I can just, like, I don't need to keep track of it. I can just throw it away. So cool, I found a pair. I don't need to keep it anymore. So I'm just going to do,
Pop it off.
yeah, exactly. So I'm just going to do pop. So that's nice. And then, but if it isn't the character I want, then that's not good. It doesn't really match. So I will return false. Great. But just remember that I'm returning true here. So I have this default true. That's going to be a problem eventually. So we have our stack. Every time we see an open, we push it to our stack. And every time we see a close, we say, do you match my last open? If you do, I'm going to pair you up and throw you out. Not the most pleasant imagery, but so we go. If I try to close when the open doesn't match, I'm going to say this isn't a match. So that's pretty good. We're going to run our unit tests and see what happens, because I've got all my LeetCode tests here. And if I look, all my LeetCode tests pass, but some of my test cases don't pass. So here you have open close, that's fine. This worked fine. This worked fine. And all the LeetCode tests were fine. But open, nope, sorry, expand. If I look, this one, no, it wasn't, this one didn't pass. So here I had an open and open, and it's supposed to say that doesn't match, but it returned true. So when only open brackets, then false. So this isn't valid, right? Like you wouldn't look at that and say, yes, that's matched brackets. So we have a problem there. We don't want that to work. And again, it's not an LeetCode problem. So you do a LeetCode problem, you're like, I'm a genius. And then you're like, oh shoot, there's this edge case. So now we have to think about, well, what's going on here? So we have, we're not returning false. So are we supposed, like, what's going on? Can anyone suggest a hint of what we should do in the case where there's just a bunch of open brackets left over? If there are leftover open brackets, it means not everything was matched.
So you have to make sure the last element in the, what were we putting in? The last character in the string is a closing bracket.
So if we are in the case where you could do that, that's definitely a valid example, except, maybe there's a different way to look at it. I'm trying to think. You could check if it's a closing bracket, and then you would know if there weren't enough closing brackets. But you could also have a string that looks like this, and that's not valid, even though the last character is valid.
We make sure the number of closing brackets equals the number of opening brackets.
Right. But if at the end of this for loop, you have more opens than closes, what will your stack look like?
So we have a suggestion from the, Samantha's actually, you can go ahead and say it.
Thank you, sorry. I was just saying, before you return true, you can check to make sure that the stack is empty. Because if it's not empty, then you should not be returning true.
Right. So if we have a bunch of opens, our stack is going to get all of these. We're never going to check this here. We're never going to hit this return false. But this doesn't seem right. So what we can do is we can return stack dot is empty. So if the stack is empty, it means all of our opens have been closed. We have no leftovers. So that's one way to do it. That's sort of the kind of efficiency of, you never actually have to keep track of how many you matched or not. You could count, like you could say, count the characters. That's one option. And in some algorithms, that is the better option. For this particular one, since we don't need to track, we can just say, did I match everything? And then return whether the stack is empty or not. So we can try running our test cases again and see what fails. So the only test cases that are failing for me now are the ones that I've subject myself to. So I've decided that I'm going to tolerate invalid characters, and I'm going to tolerate white space, but not invalid characters. The reason why I want to bring this one up is because there is, so if you just want to do the, sorry, there's a bunch of other code in here. If you just want to do the LeetCode problem, that's enough. But there is one thing about the invalid characters to come up with. So I'm just going to do invalid characters. Okay. So if I get a string, actually I have it in my test cases. So if I get a string that looks like this, here, match brackets, has a bunch of random junk in it here. What I want to do is I want to throw an exception, or I want to say it's not valid. But we want to do something here. I've also decided that I'm okay with white space. So how do we throw an exception when I get like ABC and exclamation mark, but allow white space? So here, oh my goodness. We have this else statement that's a catch-all. So if it's anything but an open, we're just going to try to match it. But if we get like a space character like that, why would we try to match it? Like, obviously it's not going to be in there, and I'm okay with spaces. So we're going to do, if this is in close, I'm only going to try to do this matching thing when it's a closed bracket, because otherwise I'm just not going to worry about it. because if I have a bunch of spaces or I have like ASDF, like it's not going to match, and I'm not going to worry about it. So that's a small change I can make, and it's just going to skip all the other characters. So I can run this test here, this one that tolerates white space. And oh no, that one's not the right one, because that was the, come on, mouse. The white space one will pass because it's got a whole bunch of extra characters in it. Still fails. This is what I get. Invalid characters, only close brackets. Only close brackets is failing. Let's see. See, this is what happens. You do test-driven development, and
I was going to ask about that one actually.
yeah. So if the character is in opens, we push it. Otherwise, if it's in closes, we try to match it. Otherwise, we skip it. So let me see.
The stack is still 0
What do
for
you mean?
that one.
Close brackets.
Because you're not pushing those into the stack.
Okay, yes. All right. So did you see the empty stack exception? Because maybe, yeah, so we've got empty stack exception. I didn't pay attention to that. I'm just ignoring my failing test, but I got an empty stack exception, which is an excellent point, because this isn't valid, and we have to go back here and check. So kind of easy to do, hopefully. If stack is empty, return false. So if I get here and the stack is empty, return false. Now, this is probably what your code is going to look like when you are interviewing. It's just going to be like, I actually do have like arrows that go into my whiteboard code. It can get messy. So let's see, let's try to run all my tests. I just run all the tests. I don't really have to. I just, what I end up doing. So that one passed, so that's nice. The only one that's failing is I want to throw an exception when it's not white space. But otherwise, we're tolerating, you know, white space. We've got our opens, all opens and all closes. And I do like that the additional test cases that have been added are slightly better than the LeetCode ones. So sorry, I'm proud of myself that I can think up test cases. The only one that's left is throwing an exception. And I'm not going to make you walk through that one with me, but I can do this one. I will show you how this is going to look. So I'm going to allow white space, which is fine. If character not in white space, actually like how Colin does this, they say not in, which is kind of funny. I'm going to throw an exception. I have copied a few things here to make my life a little easier. I'll create my custom exception class, and then I will throw invalid character exception. So here I've just, like, all of this is filtering, basically. I only look at opens or closes, but if I encounter something that's not white space or not allowed, I'm going to throw an exception. So I'm blasting through that one because it's not really necessary for the data structures and algorithms. But if you are interested in development and, oh dear, I'm throwing exceptions everywhere. This is what happens when you're live coding. Non-bracket, non-white space character found. Yeah, I'll have to rearrange it. But this is the fun part about doing this type of coding. Character. Oh, you know what happened here? That's what happened. I put it in the wrong level. Jose, I'm trying to keep up with chat. Yeah, this is pair programming. If you want to do pair programming, I don't necessarily recommend streaming it in a recorded event. I've actually practiced this a bunch of time. I have recorded me doing this problem on YouTube. But we do have all of our test cases passing, which is great. We found bugs, we made bugs, we fixed bugs. So that's TDD doing the stack bracket matching problem. So as an alternative to coding on paper or using LeetCode HackerRank. Okay, but when you do code this and everything runs, you still have to do your complexity analysis for time and space. So we're going to do that. So let's talk about space first. One of the things that I do to just make my life a little bit easier is I try to create all of my data structures at the beginning, because then I can keep track of all the space that I'm using up. So that's one kind of pro tip. If you don't have to put it in your for loops, try to put it at the top, because I can look at this and say, what's the size of my map? It is 3. So that's constant. We're gonna put O of 1 here for constant space. My list is also size 3. My white space list is size 3. So all of these are constant. So we've got constant space here. Then we have our stack, and we're gonna wait until we look at our for loop here before we decide how big is this going to get. But you can think about how big could it possibly get? What would happen if we just put everything in the stack? Like, why would that happen? So we have our for loop, and every time we go through our for loop, we will either push something to the stack or we're gonna pop something from the stack, because peek doesn't change it. There's an if statement here, so it's possible if we had a string that just looked like this, and that's of size n, then what would the maximum size of our stack be if we just had n open characters? All right, I got an n. And what would the maximum size of our stack be if we just had closed characters? Yes, that would be 0. So depending on the string we get, our stack could be 0 or it could be n. If we have all opens or all closes. But the most it could be is O of n in terms of the input. We're not going to get like double or triple or anything like that. So we'll have O of n space. And those are the only outer structures. We want to double check the variables we're creating in the loop as well. These are the only ones. Those are just constant time as well. So they're just one item. So we're not creating any additional data structures. So the space is O of n. Got that covered. Now we go into time complexity. So we have our for loop here. This is going to be running. So if I have n characters, n opens and closes, and actually just any characters, how many times is this for loop going to execute?
Is that O of n squared?
So just the outer loop. So how many times is the outer loop, this one, going to execute?
O of n?
N times, yeah. So we're saying for every character in the input, we'll execute once. So we have n times there. We're just going to put n times for this loop. Okay, so let's look at what's inside the loop. Comparisons, assignments are all constant time. So this comparison here, this if statement, character and open to close, it's a good point actually, because I used a map. So I'm just talking to myself here. I used a map for this. When you use a map, you run a hash function on the key to determine if it's in there. So that's a constant lookup. Hash maps have constant lookup. So this particular operation is O of 1. But I used a list for closes. This is going to have to go through each of the 3 items in closes. But that's always going to be 3. So that's actually constant time as well. So it's O of 3, which we write as O of 1. So this does loop over a list, but the list is always of size 3. The same thing happens in this white space one. It also checks a set. Now the set could be a hash set, so it could be constant time. We'll be pessimistic here and we'll call that O of 3 as well. So for all the outer ifs, we just have constant time. Now let's dive into the inner parts of it. So you want to go through each line and say how much is the time complexity of this.
Hey Alicia, about line 19,
Mhm.
when you say you use closes, could you have just use open to closes dot values?
Yes, so you can do that as well.
And would that have just been like O of 1?
It
Like
would
keys?
still be O of 3 because the
So-
values, it depends. So
Why is keys not O of 3 then?
because that's using the, you know that the character is
Oh.
hashed to a hash code, and that's backed by hash set. And then this is getting kind of low levels. But the lookup for the key is constant time.
Gotcha. The value isn't okay.
Yeah, so you could get the value in constant time by the key, but when you get values, it's going to be some sort of structure. When you do, so if I am using my IDE and I say dot values, here it's going to tell me it's a collection of characters. And that doesn't tell me if it's a set or a map or a list, but I have to assume the worst. And the worst would be O of 3, which is still constant time. Like it's always going to be 3. But it's a good point. I could use open to closes dot values instead.
Gotcha. Okay. Thank you.
No problem. And then if we're looking here at stack dot push, what is the time complexity of a stack push operation?
That's O of 1.
Yes, we have learned that today. And peak, if we're going line by line, so, oh, that's copy paste. So if we're going line by line, the next one is checking if the stack is empty. That one's going to be, I'm going to tell you that one's constant time, unless you look at the list at the first node, it doesn't have a next. So if you're implementing it as a linked list, it's constant time. So from today, what is stack peak? Is that constant, linear, factorial?
Constant.
Yep. And we know that looking up from a hash map is also constant time. Comparisons are constant time. And then we have another operation pop. And that one is?
That's constant.
Yep. So if we go through our lines, all of this is constant time.
Ooh.
So now we just look at the outer for loop. So we can say this entire block is constant time. So it's going to be n times inner block, which equals O of n. So this algorithm is O of n. So that's nice. So we have O of n space and O of n time. And of course, this one is, you don't want to like, sorry, this is O of 1. You don't want to have this beautiful algorithm. You're like, this is, linear time. And then at the very end, you do some sort of, I don't know, you sort it or something like that. But yeah, so everything in here is O of 1. So we have O of n space and O of n time. So that's pretty good. You can't really do better on this one. I have thought about using like regexes, but I think that's a really dark place to go. Regexes can be frustrating.
I love regular expressions. I don't know what it is.
Well, that's what I was thinking about. For this character in open to close, you could do something like character dot matches. Oh, you can't actually, we'll change it. We're going to do some weird Kotlin stuff here. And you can write your regex. We're going to say that we're going to create a group. I apologize that I'm going into this. Escape character here. Oh my goodness. And we're going to allow it to be 1. Groups. So this is like, I don't really think my code like this, but you could do regular expressions. If you really felt like you wanted to go out and do your own thing, you can create a regular expression to match for this. And if you don't know what regular expressions are, that's fine if you want to learn about them. let us know and we can try to work it into another talk, because it's a fun thing in computer science. Thanks, Meg. I have used regular expressions at work last week. So that's fun. And thank you for improving this, because now I don't need that extra list. So I have saved 3 space in this problem from doing that with you. I'm going to stop the recording now, but that doesn't mean that I'm not going to do the other problem. But I just want to formally end the recording here, and then we can do the wrap up and follow up with the next problem if people are still with us.